All right, so yesterday you guys learned a little bit more about subatomic particles, and you learned about how the number of protons identifies what the element is. So magnesium, for example, always has 12 protons, and that number of protons is equal to the atomic number that you can find on the periodic table. You also learned or were introduced to isotopes. Isotopes are the same element, but they have a different number of neutrons. And because they have a different number of neutrons, they're going to be the same element, but they're going to have a different mass number as well. So if we take a look over here at this sample, it says how many isotopes of magnesium are in the picture. So we're looking for differing mass numbers. So I can see that this magnesium has a mass number of 24, and there's a bunch of them that have 24. So I'm just going to color those in blue. 24. That says 25, 24. I think that says 24. A lot of them there say 24. Okay, so we definitely have one isotope that is magnesium 24. I also see a magnesium 26, at least one of them. I think there's another 26 right there. And then we'll color the last isotope that I believe I saw, which was magnesium 25. So I think that one says 25 and that one says 25. So there's a lot more magnesium 24s, as you can see. But short answer to this question, how many isotopes of magnesium are in this picture? Well, there are 3. Specifically, there is magnesium 24, magnesium 25, and magnesium 26. All right, so that's great. You learned about isotopes. You know how they differ in terms of the subatomic particles. But how do we know that these different isotopes exist? Well, that brings us to mass spectrometry. So this is a really complicated process, and I'm going to simplify it for you, and then I'm going to explain how this process then spits out data to then basically confirm that there are different isotopes of the same element. So what happens is a sample, and let's just use magnesium since that's what we're talking about. So a sample of magnesium is put into this apparatus, and as it enters, it heats up and the magnesium essentially would vaporize. And so then as it vaporizes, the ions that are created, because the electrons become excited, go through this accelerator, and there's a magnet here, and that magnet basically makes the different isotopes of magnesium come off and be deflected to different areas of this detector. So for example, we said on the last slide that magnesium has 3 different isotopes, magnesium 24, magnesium 25, and magnesium 26. And remember that the 24, 25, and 26 are the mass numbers for magnesium. Now, because they have different masses, they're going to hit the detector at different spots. And so the data that then is spit out from this mass spectrometry experiment is data of abundance. So we can see that over here on the y-axis, we have percent abundance. So this is the amount of magnesium atoms that basically are hitting the detector. And we can see that this says mass charge. Often this is just atomic number. So, atomic mass. So we have an atomic mass of 24, atomic mass of 25, and an atomic mass of 26. We can see that clearly, just like on the last slide, the magnesium 24 is the most abundant, or it's hitting that detector much more frequently, specifically 78% of the time it's hitting that detector, whereas the magnesium 25 is hitting the detector 10% of the time, and the magnesium 26 is hitting it 11% of the time. So let's continue with this here. So what then is an average atomic mass? Now that you understand a little bit more where isotopes come from, let's talk about the average atomic mass. You would think from the data on the last slide that if you were to determine the average mass of magnesium, we know that the way that you calculate a mass is you add up the data points and then you divide by the total number of data points. So 24 plus 25 plus 26, and then you would divide by 3. That average would come out to be 25. So you would think that then the average atomic mass of magnesium would be 25, when in fact it isn't. So let's talk about that. So in order for us to understand, we have to talk about abundance. So which isotope of magnesium is the most abundant based on that picture that we talked about at the start? And you guys could see clearly that as I was coloring those magnesium atoms in with differing mass numbers, that magnesium 24 was definitely the most abundant. And we also looked at data that confirmed that on this slide, that the magnesium 24 is much more abundant. So what that means is if we took a sample of magnesium from the Earth, the majority of those magnesium atoms are going to have 12 neutrons or have a mass number of 24, which is why we call this the most common isotope. So the most common isotope is the most abundant atom of all of the isotopes of that particular atom. Then it says, which isotopes of magnesium are not as abundant? Well, the other two clearly are not as abundant. So magnesium 25, it exists, but it's not as abundant. And then magnesium 26 also is not as abundant. So we would then call these uncommon isotopes. So these are atoms that have mass numbers that are not as abundant. And we can also see from the data on the last slide, same thing, the magnesium 25 has a 10% chance of hitting that detector if we took a sample of magnesium from the Earth, whereas magnesium 26 has an 11% chance. All right, so how does this relate to the periodic table? So all of you guys have probably already know this, or at least have some knowledge of it, that this number here on the periodic table, and I have a whole periodic table over here. So we have we're talking about these numbers that are decimal places on the periodic table. So you'll notice that on your periodic table, all of the elements have these numbers underneath the element symbol. So we're still going to talk about magnesium, and so we're talking about this 24.305. This is called the average atomic mass. But like I was saying on this last slide here, if we took a pure average, we would have thought that the average atomic mass was 25. The reason it's not 25 and it's closer to 24 is because 24 is more abundant. And so the average atomic mass is calculated. It's a weighted average mass of the atoms in a naturally occurring sample of the element. So on the next slide, we're going to talk about how the average atomic mass, which is on the periodic table, is calculated. It's also important to note that these masses on the periodic table also indicate the most common isotope. So because this average atomic mass is 24.305, we can then say that the most common isotope has a mass number of 24. So the majority of magnesium atoms, if they were taken from the Earth, are going to have 12 neutrons. All right, so let's calculate. First, why don't you guys take a second and make sure you write this equation down here. So this is how we calculate the average atomic mass. So it says average atomic mass equals, and you're going to take let's use a different color here. You're going to take the mass of isotope 1, so the mass of one of the isotopes, and you're going to multiply it by the abundance of the isotope. So often they're going to be reported in percentages, so you need to make sure that you put them into decimals. And then you're going to add that to the mass of another isotope and multiply the mass of that isotope by its abundance. And then you're going to add that to, and you'll continue. So if there's 3 isotopes, then you'll continue that process, the mass of the isotope times the abundance. And then you add them together to calculate the average atomic mass. So let's do this example. And I've already written out the numbers, so let me just grab that data so I can go through it a bit quicker for you. It says using the data, calculate the average atomic mass of magnesium. And we're given this data, which is also from the graph on the previous slide. So we can take our average atomic mass and say that that's equal to, well, we don't want that scribble mark. Let's delete that. All right, so the average atomic mass is equal to the mass of isotope 1. So we'll say the mass of isotope 1 is that first one, and it says that the mass is 23.9850. And then we can multiply that by the abundance in decimal form, so 0.7899. And then we add that to the mass of isotope 2, which is 24.9858, multiplied by the abundance in decimal form, so 0.1000. And then we can add that to the third isotope because magnesium has 3 isotopes. The mass of that one is 25.9826. And we multiply that one by its abundance in decimal form, so 0.1101. All right, and so when we go through, it's kind of a little bit slow here. When we take that abundance times the mass of the isotope 1, mass of isotope 2 times its abundance, and then mass of isotope 3 times its abundance, we end up with an answer, and I already plugged this into my calculator. We end up with an answer of 24.305 AMU, or atomic mass units. Okay, and so this then is the average atomic mass. It's not a pure average because it's incorporating the abundance of each of the isotopes. And what you should notice here as well is that 24.305 matches that average atomic mass on the periodic table. So that, again, just to reiterate, that mass, average atomic mass on the periodic table, it's a clue as to what atom or what isotope is the most abundant in the Earth's crust.